So good morning, everyone. This is lecture number 5. We are dealing with Young's double slit experiment, and let's see. We'll move ahead and try to wrap it up. Not by today, probably by tomorrow, so that we can move on to the next topics. We are discussing Young's double slit experiment. Let us go. Let us have a quick recap of this. We are basically dealing with this diagram, and this is the only diagram that we have to deal with. What we have assumed over here was the position of any point P, and we had to find out whether constructive interference occurs here or destructive, and what is the condition for constructive or destructive interference happening there. We have two waves, one coming from S1, one coming from S2. S2 wala wave, S2 wave is traveling more distance. So the path difference is S2P minus S1P. If I would have taken a point down below, let us say here at point B, then you could have seen that this S1 wave would have taken more time compared to this S2 wave. So in that case, the path difference would be S1P minus S2P. Do we understand this? So depending on where you have taken the point, if you have taken the point on the top, above C, S2P will be more. If you take the point below C, S1P will be more. We had also found out that the path difference is S2P minus S1P, and we had devised the formula for path difference, and the formula for path difference subjected to the condition that D is very smaller. Small d is very smaller compared to capital D. We had got the condition that this path difference is small d sine theta. We all remember this, yes or no? Then we had seen that this path difference, which is d sine theta, for constructive interference, d sine theta will be equal to n times lambda, and d sine theta will be 2n minus 1 lambda by 2 for destructive interference. Do we understand this? This is the general formula which is valid. Now I can put one more condition. Remember, up till now I had used one approximation that small d is very small compared to capital D. Now I am going to use one more approximation. What is the approximation that I am going to use? If theta is very small, if theta is very small. Now, theta very small still means the same thing. Theta meaning very small is that this distance d is very large and the point P is very close, because you will not have a very large screen. The distance is very large and the screen is small. So point P is actually very close. So we can say that in most of the cases, unless I give you a question where theta is not small, theta is always going to be small. Now, if theta is going to be very small, then you must remember that the value of tan theta becomes equal to sine theta, and this approximately becomes equal to theta. We all understand it? This is simple maths. Yes or no? Huh?
Yes, sir.
In that case, what happens, my dear friends? Your d sine theta becomes equal to d of d tan theta, and this d tan theta becomes equal to n lambda. Now, what is this tan theta equal to? What is this tan theta equal to? So I go back to the original diagram. This was the diagram that we discussed. Before this diagram, we had this diagram, and in this diagram, if I just rub the part which is not necessary right now, so I rub that part which is not necessary, you can see I told you two angles are theta. One angle is this that we have already discussed. If the distance is very large, I told you that this angle is also theta. Yes or no? From here, you can find out the value of tan of theta. Tan of theta will be perpendicular divided by base. Yes or no? Perpendicular is y, base is d. So we have the formula for tan theta in the approximate condition. And what is the formula for tan theta? It will be d into y by capital D. that will be equal to n lambda. Now I can write y is equal to n times n times capital D by small d lambda. This will give me the position of nth bright fringe. Do we understand this? It will give me the position of nth bright fringe. What is the value of n? For n is equal to 0, I will get the central bright fringe. Do we understand this? For n is equal to 0, I will get central bright fringe. For n is equal to plus 1, I will get first bright fringe above C in the upper direction, in the upper region. If I put n is equal to minus 1, I will get the first bright fringe in the lower half. What do I mean by this? I hope everyone is noting this down. What do I mean by this? So I take you back. Everyone has noted this down? So I'll take you back to the diagram that we had drawn: bright, 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 dark, 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 bright, 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 dark, dark, dark. So the green one, n is equal to 0 is your this fringe, the central bright. N is equal to plus 1, n is equal to plus 2, n is equal to plus 3. This is n is equal to minus 1, n is equal to minus 2, and n is equal to minus 3. Do we understand this? These are the bright fringes, and these are the positions of the bright fringes. You put the value of n. If you put the value of n as 0, you will get 0. That is the central bright fringe. If you go put the value of n as 1, you will get capital D by small d into lambda. If you put the value of n as 2, you will get 2 times capital D by small d lambda, 3 times capital D by small d, and so on. Do we understand this? Now we can do the same thing for small theta. Tan theta becomes equal to sine theta. So what will I have? I have here, I will have d times tan theta will be equal to 2. Let me not use n, let me use m here so that we take them differently. 2 times m minus 1 lambda by 2. The value of tan theta is d into y by d is equal to 2m, so that they look different, nothing else. So from here I can get the value of the mth dark fringe, 2m minus 1 times d by small d lambda by 2. If I put the value of m will start at 1 or plus 1. I will get first dark in the upper region. If I put m as minus 1, I will get first dark in the lower region, and so on. Do we understand this? Yes or no? No, yes.
Yes, sir.
Okay. Now I can put these values here to show you in the diagram how it looks. So in the diagram, you already have the bright fringes marked. Let us mark the dark fringes. This is m is equal to 1. This is m is equal to 2. This is m is equal to 3. This is m is equal to minus 1. M is equal to minus 2. M is equal to minus 3. M is equal to minus 4. I hope I am making sense. Dark fringes, bright fringes, and so on. So these are the formulae that you will have to remember. Which formulae you need to remember? This one. and this one. Do we understand this? I'll give you 1 minute to note it down. Note it down. These are the only two formulas that are required in any case. And with these two formulae, you should be able to solve any question that comes. Have we noted it down?
Yes, sir.
No, sir. Okay. Shall I move forward in life? Ahead in life? Yes or no?
Yes, sir.
In this is an important note. Now, sometimes not in a JEE Main, but sometime in JEE Advanced, instead of giving you vertical slits like this, see, this is a vertical slit, S1 on top, S2 on the bottom. They could devise a question where the slits are not vertical, but the slits are horizontal. Do you see? In diagram number A, we have vertical slits. In diagram number B, we have horizontal slits. Do you understand this? So now we are having, what should I say, interference from horizontal slits. Horizontal slits, we are having interference. Now, if we are having interference from horizontal slits, the part difference, in this case, the part difference, this was the part difference, yes or no? And that part difference was d sine theta, where this angle was theta. Here, if this angle is theta, the part difference becomes this one, it becomes d cos theta. Do we understand this? Note it down. If you want to draw the diagram, you can draw the diagram. I'll give you 1 minute to draw it. Have you noted it, beta?
No, sir.
Okay. Shall we move ahead?
Sir.
Yes, sir, or no, sir?
Yes, sir.
Okay, so the next heading that we are going to write is known as your fringe width. What do you understand by fringe width? And that is right on your screens now. Fringe width. Now, what do you mean by fringe width? It is the distance between any two successive bright fringes or any two successive dark fringe. It is denoted by the letter beta. So distance between what? Distance between any two successive dark or bright fringes. You take any two dark fringes successive. If you take first fringe as the nth dark fringe, then you take the next fringe as n plus 1 dark fringe. You find out the distance between them. That is your fringe width. Fringe width is denoted by the letter beta, and if you put the formula for dark fringe or the bright fringe, you will end up with the formula, and that will be capital D by small d times lambda. So you put this, you put the value of n as n, and then you put the value of n as n plus 1 or n minus 1. You will get the value of beta as d lambda by capital D lambda by small d. We will show you one more diagram. You may not have to draw this. This is just for your understanding of the concept of this fringe with beta. This is the fringe with beta. This is the dark fringe. The dark fringe. Then you have the bright fringe. Then you have the dark fringe. To find out the distance between any two consecutive dark or any two consecutive bright fringe, that becomes your fringe width. This is, do we understand this, yes or no? From the diagram it is
Yes,
clear.
sir.
You don't have to draw this diagram. This is just for your understanding, that you understand what you are doing, nothing else. You don't have to draw any of these diagrams. Just for your understanding, I am showing it to you. If you have to draw, you can draw the diagram on the left hand side. That is much more than enough that you will ever require. I'll give you a minute to do this. Don't waste your much time in drawing both the diagrams, because it's just for your understanding, that you understand it. What is fringe width? Once you are done, please let me know so that I can move ahead in life. Are we done? Have you noted it?
Yes, sir.
The next point, which again might not come in a JEE main, might come in a JEE advanced, is known as the angular width, or the angle that the fringe makes at the center point 2. This is the diagram that is going to tell you beta, as you can see, is your fringe width. Alpha, my dear friends, is known as your angular fringe width. And as you can see from the diagram, very straightforward, your alpha is nothing but your beta divided by capital D. All these small points sometimes comes, and if you don't know them, you just don't know them. So you can write it beta, you know the value of beta, D lambda by small d. So you can write this as lambda by small d. All these relations are so important. If you can remember them, keep them in your mind. You are going to have a good time solving the question, because the questions are going to be just formula based like this. But you have to remember them to solve them. I'll give you a minute to note this down. Have you noted it down, beta? Angular fringe width.
Yes, sir.
Okay, then we shall note some important points about fringes, and we are going to cover everything that has come up till now in any exam in with these important points. All these are not important points, they are questions that have come in the examination hall. So please note them very, very carefully. We all know this thing, this is just a way of remembering this, way of remembering this. If you can remember them in a number of ways, the better it is going to be. The first point, we all know this, all fringes are of equal width. This is a very important point, because in the next chapter, in the next topic, they are not going to be of equal width. Each fringe width is lambda d by small d. We all know this. Fringe width, you can call it theta or you can call it alpha, is lambda by d, small d, or beta by capital D. I hope all of you know this. We are going to write all these formulas one by one, so that if even if you miss it one times, you cannot miss it the other time. Do we get this? Yes or no?
Yes, sir.
Now, this fringe with beta is equal to lambda d by small d. Yes or no? Now, you can say that if everything remains same, beta is directly proportional to lambda. Yes or no?
Yes, sir.
Now, if you dip or if you put the Young's apparatus in a different medium than air, if this Young's double slit experiment is conducted in a different medium, the fringe width will change. Why will the fringe width will change? Because the value of lambda will change. So value of lambda in any other medium will become lambda divided by mu of the medium. Do we understand this? Because the wavelength of light changes. Yes or no? Do we understand this?
Yes, sir.
So in that case, your beta in the medium will be equal to how much in terms of your original beta, your beta in the medium will become beta in air divided by mu of the medium. Do we understand this? Yes or no, no or yes?
Yes, sir.
Please note all of these points very, very carefully because one of these points is going to come in your examination hall. This is point number 2. You can take the example of water. Mu of water is 4/3. If you dip this apparatus in water, your fringe width in water will become 3/4 times fringe width in air. Do we understand this? Yes or no? No, yes. Every point needs to be noted very, very carefully. Every point needs to be noted very, very carefully. Next point, fringe width is inversely proportional to the slit distance. If you increase the slit distance, fringe width decreases. If you decrease the fringe distance, the slit distance, fringe width increases. Each and every point is a potential question that has come once, maybe more than one time. This apparatus dipped in some other medium. It is a very favorite question of JEE Advanced. Whenever they are going to give you a question on young double slit experiment, it probably would be in some other medium, and then they might ask you multiple questions based on this. What happens to the fringe width? What happens to lambda? What happens to this? What happens to whether the fringes are shifting or not? Everything is there. Do we understand this? Yes or no?
Yes, sir.
The next one is this. The position of the nth bright fringe from central maxima is, we know that it is n times lambda capital D by small d. You can write it at n times beta. Do we understand this? So if beta changes, that was the question I asked you. If beta changes, the position of the bright fringe will also change. Do we understand this?
Sir.
The central bright fringe always remains at the center. The central bright fringe is also going to change. And I'll tell you in the case when it changes. In this case, if lambda is changed, all the fringes shift, but the central bright fringe remains at the center. I hope we understand this. Have we noted this down? Have we noted this down?
No, sir.
Okay, I'll give you time. Note it down. Are we done?
Yes, sir.
Okay. We move ahead. We have seen the position of the nth bright fringe. You can also look at the position of mth dark fringe in terms of beta. Do you see this beta here? Beta is lambda capital D by small d, so you can also write it in terms of beta. The same formula can be written in terms of beta rather than writing it in terms of lambda capital D by small d. You can also write it in terms of beta. Noted it down?
Yes, sir.
Now, one question which has come in one of the 5-6 years before JEE was this. There are N1 fringes visible with wavelength lambda. How many number of fringes will be visible if the wavelength is changed to lambda 2? So you can see the fringe width is proportional to n into lambda. So n into lambda will remain constant if all of the other things are same. That means n1 into lambda 1 will be equal to n2 into lambda 2. Fringe width. Do we understand what I'm saying here? So just note this down because this is a question that has come from one of the previous years. I'll give you a minute to note it down. Have you noted it down?
Yes.
Then some important points. Condition for good interference. What are the conditions? And these conditions have come in exam before. They are obviously not going to ask which of the following is a good condition for interference. They will not ask it that way. They will do is they will twist the statement and then they will ask you as a option. For example, the first condition for good interference is the phase difference should remain what? Phase difference between the two waves should remain
Same.
well done. Not same, constant. Yes, constant and same are same. That means the sources must be coherent. If the sources are not coherent, so they will not ask you directly. What they will do is probably they will put one source of light here S1, they will put one source of light here S2, which may not be coherent sources, and they will tell you frequency are same, wavelength is same, what will be the interference pattern. Then you must understand that two sources of light which are different, not created from a single source, cannot produce coherence, cannot be coherent, and therefore they cannot interfere. Do we understand this? They will not ask you straight away, they will ask you in a twisted fashion. Yes or no?
Yes, sir.
Frequency and lambda must be same. See, when you say phase difference is same, that is wrong. Phase difference must be constant. Frequency and lambda must be same. So if one wave has a frequency of 60 hertz, the second wave must also have the frequency of 60 hertz. That again means that the waves must come from coherent sources. Do we understand this? Yes or no?
Yes, sir.
Light must be monochromatic of single wavelength. If it is not of single wavelength, then we don't have interference. Lambda, everything depends on lambda. If lambda is different, if you use light of different colors, fringe width will be different. You will not get interference pattern correctly. The amplitudes of the wave must be equal, nearly equal. Amplitudes must be nearly equal. It will be best if both of them are equal, because if amplitudes are equal, the maximum intensity becomes 4 times I naught. Do you remember this? Minimum intensity becomes approximately equal to 0. Dark fringes become completely dark. Bright fringes are very, very bright. Sources, the coherent sources must be close to each other. If the sources are not close, remember, if the sources are very far, beta becomes very small. If the fringe width becomes very small, you will not be able to resolve, you will not be able to see which is the dark fringe, which is the bright fringe. You want fringe width to be more. Therefore, sources have to be close from each other. I hope we understand this. Yes or no? No, yes.
Yes, sir.
These are the important points. I will give you a minute to go through these important points, everything that we have done, so that I can now give you a question based on this. Are we done?
Yes, sir.
Here is the first question, and as I told you, every point is given for a reason. This question has come in JEE, this question has come in NEET, this question has come in PETs, PMTs, many times. In Young's double-slit experiment using sodium light, wavelength is constant. 92 fringes are seen. If the color lambda is changed, how many fringes would be seen? It does not get simpler than this. Remember, these questions are more or less, you know them or you don't know them. If you know them, you can get them correctly. If you don't know them, it will take some time for you to, if you don't know them, you probably will not be able to do them. Yes, my dear friends. Any answer for this one?
Option D.
Option D is the correct option. How are you supposed to do this? I already n1 lambda 1 is equal to n2 lambda 2. Yes or no?
Yes, sir.
The first n1 is 92 and lambda 1 is this one 5898. Lambda 2 is given as 5461. You just have to calculate the value of n2. N2 will be n1 lambda 1 divided by lambda 2. That is how you can solve the question. Do we understand this? Yes or no?
Yes, sir.
But actually, there was no need of even calculating it. You see, if you can use your brain sharp enough, you don't have to calculate anything and you will still get the answer. When I look at lambda 2 is less than lambda 1. Yes or no? Lambda 2 is less than lambda 1. That means n. Oops, why I'm writing ta? That means n2 will be greater than n1. There is only one option where n2 is more than n1. That is option number D. You don't have to calculate it. You can do this in 2 seconds. Don't have to calculate it. That is why I say use calculations to bare minimum. If you see that n2 is going to increase, just look at the option which has increased. And if luck favors you, you might only have one option where it increases. And that is the correct option. You don't have to calculate it. Be smart. JEE Main is about how smart you are, how smartly you can get the answer. Remember, you only have 1 hour to solve 25 questions. On an average, you get 2 minutes to solve one question. There will be at least 10 to 12 to 15 questions, which could be done in 5 to 10 seconds. If you are smart enough to do them, well, you will score heavily in that exam. If you're not smart enough, you might lose valuable time in solving that question. And time is a luxury that we don't have, and time is very less. When you are sitting in the examination hall, you would have seen this. Here comes the next question. Let us see who gets me the answer first. Remember, they are not going to ask the question straight away. They will obviously turn and twist. This is the question that is coming. In a young subversive experiment, an interference pattern is obtained on a screen by a light of wavelength 6000 Armstrong unit coming from two coherent sources S1 and S2. At a certain point P on the screen, third dark fringe is formed. What is the part difference in microns? 10 to the power minus 7 is micron. They are not asking these questions these days, so they may not ask micron and millimeters and centimeters. Anyways, you have to be smart enough. Smart enough, you are good enough. Question number 2. On your way. Get set, go. Just my dear friends. Any hope? Yes, bacha.
Option B.
Option B, 1.5 is correct. Basically, they're asking you the part difference, delta x, for the third dark fringe. You already know part difference for the third dark fringe. So it is 2 into 3 minus 1 into lambda d by 2d. Yes or no? Or I am doing anything wrong? Remember, it is odd multiples of pi. I was multiplying it wrongly by the fringe width. So it is 2m minus 1 into lambda by 2. You put the values, you get the answer, and you stay happy. Do we understand this?
Yes, sir.
Simple questions. Remember, these are the same questions that you will see coming in your exams. Be patient. If a question of wave optics has come, that means it has to be done. It has to be cracked, whether it is JEE Main or it is JEE Advanced. It has to be a simpler one. This question has come in JEE many times. It was the previous question. The first time it came was in Orissa JEE. These are the same pattern of question that you will find, and same question gets repeated, sometimes even with the same values. In a young double slit experiment, the slit separation is 1 mm, small d. Screen is 1 meter. You can see 1 mm and 1 meter. 1 mm is very small, 1 meter is very big. For a monochromatic light of wavelength of 500 nanometers, the distance of the third minima from the central minima. The distance of the third minima from the central minima. Remember, here they are not asking the path difference. Here they are asking the distance of the minima. Difference between the previous one and this one. Anyone with any answer? Okay, I'll give you time. Think you need time. Time is a luxury that we don't have. But still, everyone needs time.
Option B.
Option B, I've got an answer. Option B. And this is correct. We just need to change the formula a bit. Distance of the minima, we had to find out distance of the mth minima. In this case, it was the third. So let me write it as third. 2 into 3 minus 1 into capital D. Capital D is 1 mm, 1 meter multiplied by lambda. 500 into 10 raised to the power minus 9. You don't have to do minus 9 because the answer is in okay, you have to do 10 raised to the power minus 9 because the answer is in millimeters. So you might, all the answers are in millimeters, so you can actually leave this 10 raised to the power minus 9 and so on, because it is not going to make much of a difference. Divided by 2 into 1 mm. You just have to calculate this. Remember, when all the units are same, again, one more tip. If all the units are same, do not worry about these points. Do we understand this? If all the units of options are same, do not worry about zeros. Even you don't need to worry about these two zeros. Are you getting my point? Yes or no? You only need to worry about these zeros when the answers are in different units. Here, all the answers are in the same unit. So forget about the Forget about the multiple 10 raised to power minus 91. You can let go zeros. Just get the value, get the answer, and stay happy. I think you are getting option B from here. Yes or no? These are how you get smarter in the examination hall. And as the questions comes, and that is why I'm taking question from previous year, because I can tell you all those short tricks. They are not tricks, they are just smartness. You are just being smart. Let's see this question. One of the latest question that came in, I think JEE of the year 2019 or something. Don't remember. I don't recollect the year. It came in my time PMT. There was PMT that during my time. Not my time, it's 3 years after my time. The slits in a young double series payment have equal weights and the source is placed symmetrically related to the slits. The intensity of the central flange is I naught. If one of the slits is closed, what is the intensity of this point? They'll ask the question in such a way that confuses you. If you can get out of that confusion, you can get to the answer. Yes, the answer is
D, sir.
4 times I naught. How it can be? You put, see, the original intensity is I naught. How it can become 4 times I naught? The answer is logically flawed. When they have two slits, you have intensity I naught, you cover one of the slits, intensity becomes 4 times. It is not possible in this universe. Let us remain in this one. This is a good universe, F is equal to MA.
Option B.
Option B, yeah, it is the other one. See, you said the other one. So remember, it's not 4 times, it's I naught by 4. We understand this, yes or no? Now,
Yes, sir.
once you cover one of the slits, nothing is going to happen, no interference. So you will get whatever intensity that is coming from slit A, the intensity that is coming from slit. The confusion here is they have said I naught. In the questions in the theory part, what we had done, the maximum intensity at the central maxima was 4 times I naught. That is what we had written. We had written the intensity of one of the slits as I naught. Here it is ulta. They have given this as I naught, and let me call this as I. Do we understand this? That has been the change here. Do we understand this? Maximum intensity is I naught, which is 4 times I. Now, if you close one of the slits is gone. There is no interference, my dear friends. If there is no interference, whatever intensity is coming from one of the light, the same is the intensity at the central point. And what is the intensity coming from this light? It is simply this I. Oops, this I is also one. It is simply this I. So the intensity now becomes I. The intensity before was 4 times I. Now it is I. So the answer is I naught by 4. Do we understand this, or is it going about it saying bye bye, bye bye, bye bye? I'm going. So be careful when you are answering questions here. The only reason of giving this question was the language of this question, no diagram, nothing, plain theory. And I know that a mistake can be made. This is Young's double slit experiment, my dear friend. Everything relies on one diagram, everything relies on 2 or 3 formulae. Fringe width, if you remember any one of these formulae of fringe width even, every other formula is what you know. We will continue with more questions in the next class, and I would like to wrap up this topic in the next class, which I think there is a huge probability that I can do. So if you are done, if we do it, and if you can solve questions quickly, because there are certain minimum number of questions that we need to solve them quickly, I would be able to give you more questions. So I'll see you in the next class. Take care. Have a nice day. If you have anything, please let me know. God bless all of you.